Thank you all for joining for this session on MTech in EV technology. So we are just going to give you an overview on what is happening at Christ University and why do we offer this program called as MTech in EV technology. So this Masters in Technology in EV electric vehicle technology is offered by the Department of Electrical and Electronics Engineering at School of Engineering and Technology in Christ University. We are situated in Kengeri in Bangalore. Okay, so this is where we have 6 campuses all over India. Out of that, the engineering campus is in Kengeri in Bangalore. Okay, so as part of the research initiatives from the university, we have a lot of center of excellences inside our campus. Not only engineering related, there are something on astrophysics as well as space related also. But our thrust area is on electric vehicle technology as well as our thrust area is on software defined vehicle. So that is where the COE in e-mobility comes into picture. In our campus, we actually have two center of excellences which are collaborating together to run this program in MTech in EV technology. Okay, one of the COE is the Center of Excellence in e-mobility, and the other one is called as Center of Excellence in Frontier Material Research. So the Center of Excellence in Frontier Material Research will be focusing on material research part of it, where you will be studying or you will be exposed to battery technology as well as various types of chemistries which are used in batteries. How do we actually make a cell? All those parameters will be discussed. That is what I will shortly give you a glimpse on what is happening. Okay, so this is an overview of our campus. Okay, here we have almost 10 departments which are running in the engineering sector. Okay, and this particular department or this particular course will be in collaboration with as triple is the BOS or Board of Studies in charge, along with that mechanical department faculties as well as science and humanities related faculties will also be involved in giving you a comprehensive overview of all the aspects of an electric vehicle as well as automotive technology as such. Okay, the best part is we also have our industry partner Decibels who will be coming in, and this is purely a industry based curriculum that we have developed. So that will help our students to get completely employable. That is our critical aim of this particular course. Okay, yeah. So I'll move on to the main part of it. So these are the facilities which we currently houses in the center. So before we get into the facility, I just want to give an overview of what all things which we are focusing on. The Center of Excellence in E-Mobility, we started this in 2018. Okay, from then we have been working on various aspects of electric vehicle technology. We have three major trust areas which we work on. One is called as the energy storage system. The second one is the software defined vehicle topology or the construction. And the third one is on sustainable EV technologies, mainly related to renewable based usage. So all these verticals, we have some kind of expertise in terms of faculties as well as industry based orientation, collaborations. And also we have state of the art research facilities also, which we'll be using for developing each of these verticals. Now, in this particular MTech in EV technology course, you will be exposed to all these three verticals in different levels. Our thrust would be mostly on the energy storage part of it. Maybe 60% can be called as the energy storage part of it. Around 30 or 25 percentage will be onto the software defined vehicle part of it, and the remaining will be onto the renewable part of it. So this gives you a comprehensive analysis of how an EV or a vehicle will be made to operate on a software platform, as well as what are the energy storage requirements and how do we charge and discharge, or how do you integrate an EV to the grid. That is where we come across the concepts of power system, and all these aspects will be covered together in this particular course. So coming to the energy storage part of it, these are the facilities which we house in the Center of Excellence in E-Mobility in collaboration with Decibels Lab. So here you can see we have the cell capacity tester, DCIR, ACR testing can be done. We have thermal chambers as well as cell cyclers, which are used to test any kind of cell, ranging from coin cell to big prismatic cells which are used in actual vehicles. 3.2 volt 70 Ah to 100 Ah cells can also be tested on these cell cyclers. So using this facility, what happens is you will have a comprehensive hands-on experience on how a cell works and how do we do the cycling, what are the impacts of temperature effect on the cells, as well as you get to know how does a what are the various aspects uh, of cell or the environment which impacts the cell, how do we prolong the life of cell. All these will be provided to you on a hands-on basis. Now, if you look at companies like the OEMs which are involved, like Aether or companies like Ola, they have their factories where they have these test equipments which they are using it for their cell as well as pack manufacturing and testing. Now, when one of the student who has undergone these kinds of hands-on experience applies to such companies, you get better chances of getting absorbed because there is a huge demand of well-trained engineers who are required to work on these operational equipments, and therefore this will provide you a very good experience on how to work on various aspects of the battery. Okay. Now, if you look at the lower portion of the screen, you can see there is a image of a MATLAB figure. This is where we talk about the battery management system. So as you know, all know, lithium ion cells, which are commonly used in our attractive applications, as well as for even our mobile phone batteries as well as laptop batteries, lithium ion cell requires something called as a battery management system for its its prolonged life, as well as for ensuring that these cells perform under good condition, like they don't get into thermal runaway or any other process. So there is a lot of understanding required on how the chemistry work and how do we regulate the various aspects of operation of a cell. Okay, so that is where the battery management system comes in. The battery management system actually diversifies uh, the experience that you get from a hardware, because you have to have a lot of software knowledge also on how do we do coding, right? Or if you are working on a Simulink platform, how do we generate code from Simulink in to a microcontroller where you are dumping the code in the form of a C program? How do you generate the C code? Excuse me. So all these aspects will be covered as part of the program which we are offering. When you look at the second semester portion, which I'll take you through, when you look at the second semester syllabus, you will find something called as a digital twin. Now, digital twin is a very exciting topic which is coming up in all aspects, mostly in the area of virtual vehicles, or you can call it a software defined vehicle, or excuse me, something on predictive maintenance system. Yeah. So, digital twin is a very exciting area. Now, in the case of a cell or battery, you can actually, by the testing facilities that we have, you can actually develop the digital twin of a cell or a battery pack, which then you can use it for testing on a simulation environment, on a powertrain which you have modeled. So if you are making an electric two-wheeler powertrain modeling on the Simulink platform, which will most probably be one of the first question which any OEM will be asking you if they are planning to take you as an intern. They will be asking you to model a electric two-wheeler or electric four-wheeler on paper first, and then you have to do a Simulink modeling of that. And once that Simulink modeling is done, then you have to integrate with the battery pack and perform an analysis over a drive cycle or an inclination path. Now, if you have an experience on making a digital twin of a battery, uh, that would be providing you an exact performance analysis of the cells, which you will be connecting to the vehicle, and then you can make the vehicle operate on a drive cycle. So basically, you will get an actual performance analysis of how the battery will be performing when there is a variation happening. So all these things you can experience when you're going through the course of digital twinning, where it has a practical component also. Apart from the theory part, it will have a practical component also. So that is what. And if you look at the last image, this is a dynamometer which helps you to actually load a electric two-wheeler onto, or any electric vehicle, electric two-wheeler basically, not only electric two-wheeler, any two-wheeler onto that, and then you can make the vehicle to operate as per a drive cycle, and then you can actually get into the CAN bus of the vehicle and tap into the information, whereby you will be getting information on how the various aspects of the vehicle will be changing as per the drive cycle. Now, that is where the second most important aspect comes into, that is the in-vehicle communication, which is CAN, controller area network. So you get to get a flavor of how the communication aspect happens inside the vehicle. This is very important because apart from the energy storage part of it, now you're collecting data, and that data you're going to perform some kind of a data analysis. So that is where you're slowly edging out from the electric vehicle part of it to the software defined vehicle part of it. So that is where I would like to bring you to this particular aspect of it, which is called as case. So I don't know, have you, if you have heard about this. This is the four major trends which are now currently changing the automotive industry, and it is going to be a long-term technology shift which is going to happen. That is called as your connected, autonomous, shared, and electric platform, or case platform. Right. So here, if you observe, we are uh, if you want to get into any of these aspects like connected vehicle, autonomous vehicle, shared services, and all, the underlying base is the electrification of the powertrain, or you have to have an electric vehicle powertrain. Now, since most of the IC engine companies and OEMs are shifting their base to electric or hybrid based powertrains, the conventional IC engine powertrain is not that flexible to have this case developed on top of it. So that is where electrified powertrains are required, and that is where hands-on experience on electric vehicles are very much predominantly required for the future. So any future vehicle which you're going to see maybe 10 years down the line or 20 years down the line will be having an electric powertrain as the base, on which there might be other aspects, like it might have a autonomous feature on it, or it might be a connected vehicle, connected in the sense vehicle to infrastructure connection, or vehicle to vehicle connected, so that all these interconnections will be required for the vehicle uh, I mean, for the vehicle to move as well as for the vehicle to perform. So so case is the baseline that we are looking at in the future. And for that, your uh, electric technology know-how is very much important. So this particular MTech program, as I told, we will be in collaboration with the Frontier Material Research Laboratory, where they have facilities to have you hands-on experience on how to make a cell, coin cell. So the lithium-ion cells which you have, basically you have electrodes, you have a semi-permeable membrane in between the electrodes, and there is a motion of ions which is happening across the membrane, which is helping the generation of the flow of electrons, which is leading to electricity. Right. So you get to have an experience on how do we make a coin cell. Okay, so this glove boxes which are available here, as well as the testing facilities, crimping units, you get to make electrode, you do coating on electrodes, and using the electrode coating, you develop a coin cell. This coin cell, then you can have it tested on a charge discharge cycler, and based on that, you can make a digital twin of the cell. Okay, so once a new chemistry is developed, something like maybe now currently our research team is working on sodium ion cells, which is a completely new kind of chemistry, which is looked upon by most of the industries. So such kinds of research teams are available, where if you are out of your interest, or your know-how, you can join and you can experience more and more hands-on experiences on this. We have some tie-ups with some international universities where our students are currently working as part of their internship, final year internship, and they are working on actual cell recycling. Okay, recycling the cell. How do we repurpose the cell? All those things are taken up by the final BTech, but final year BTech students are doing them. So such kinds of exposure is also coming up with this kind of facilities that we have here. So, what is there in this program? So, as I told, the curriculum is purely industry aligned. We have very newly like, new generation curriculum that we are offering. This curriculum mostly is very much as per the current technological development that is happening. Okay, and we have a lot of industry experts who have coined in to develop this curriculum. Basically, the Center of Excellence in E-Mobility, we have an advisory board. Advisory board consists of uh, 5, 6 members who are from various OEMs in India, and these industry experts have vetted through the curriculum that we have prepared, and based on their inputs, we have made and tuned the curriculum for making the participants or students who are taking up this course to be industry ready. Along with this, as you all have been seeing, we provide hands-on learning with advanced facilities which we have here. And collaboration with Decibel Lab is one of the key factor which is driving this event or this MTech program, because Decibels is helping us to bring in industry experts as well as industry connects. Like we offer a lot of programs for Tata Motors, TVS, and all. So we get to have a flavor of industry coming in for actually in engaging in classes as well as getting them to have a know-how on what is actually happening in the automotive market. Then, as I told, focus on emerging technologies is what we basically have. Software defined vehicle is one key area which will give you a edge over other students who are getting into EV technology courses, because software defined vehicle is the future. All the vehicles which are going to come in will have a mandatory software defined features like ADAS and all coming up. So for those things, it is a requirement to have this bridging of gap done between the electrification part of it and the programming part of it. So this particular course will give you a flavor of how do we actually have hardware connected to a software, okay, and how do we evaluate it on a simulative platform, okay, like maybe Carla, where you can have a simulation of an automotive of an EV done, right, and that simulative studies, then you can have it implemented on a hardware as well. So as part of your final year project, you can work in the lab, you can make and may or be part of the existing software defined projects which we are running, or you can get into something like maybe canvas based studies that we are doing, the cyber security part of it, automotive cyber security part of it. So even though the topic is MTech in EV technology, you have a good scope to get diversified into various emerging technologies. And of course, a lot of application of AI comes in, a lot of data analytics comes in, which is very much key in your development as well as our development. So research and development opportunities is very much one factor which we are looking into. R&D is in the form of various projects which are happening. We have some industry sponsored projects. Also, we can look into some collaboration with uh, our international partners on various projects, so that you also get an exposure to maybe experience the international standards of technology which is happening in our collaborating universities. Then, of course, there are a lot of the job market is huge. Electrified job market is huge. The connected job market is huge, and students who have hands-on experience is going to be valued a lot. Okay, so this is what the case topology stands for: connected, autonomous, shared, and electrified. You can see there is going to be a forecasted shift of a huge percentage turn from 2020 status of 48%, it is predicted to be around 96% of connected vehicles. Electrification, you can see 3% is now the vehicles that we see in India is only around ranging to around 3% of the entire crowd, which is going to reach up to 24% because a lot of government initiatives are coming up where for promotion of EVs are happening. So this would require a lot of qualified electric vehicle engineers to come out, and that is what we are focusing on. right? So from E, how do we move towards C? That is the thing. You have to have a flavor of digital twinning. You have to have a flavor of autonomous modeling. You have to have flavor of connected vehicle technology. So all these is what is being offered as part of this MTech course. So semester one, as I was telling, these are the subjects which we have in the semester one topics. Energy storage, motor drives. So energy storage system, in that you will be experiencing mostly on the material part of it as well. So as I told, from the Foundry Materials Research Lab, we can have hands-on on material part of it. How do we make coin cells and all? Then storage-based studies, all those things what I explained can be will be coming under the energy storage system. Motors and drives for EV, we have various motors which are used in EVs. You know, there are basically two major sections of motors which are used, that is DC motor and AC motors. And in DC motor, we have BLDC motors, and AC motor, we have synchronous motors, permanent magnet synchronous motors, as well as induction motors. So all these test benches are available for you to experience on how do these motors work. We can perform load test on these motors. We can understand the torque speed characteristic of these motors. How do we control these motors using some electronic drives? How do we model these drives? All these will be taught by the faculties and the industry experts which we are having. So this team will help the students to be having a lot of hands-on experience on that aspect. So as I was telling, this is we are going to focus on the three verticals of our COE, which is on the sustainable EV technologies, energy storage, as well as on the software-defined vehicle. So as part of that, you can see the program elective one, which is a power system domain. The power system domain will be talking mostly on the impacts of EV or analysis of EV when it is connected to the grid. So what are the power quality issues related to that? How can we use a standalone PV system to power up the vehicle, or can we get into something called as vehicle to grid power transfer, grid to vehicle power transfer, vehicle to vehicle power transfer? Recently, Tata had launched one vehicle where they are doing vehicle to vehicle power transfer. That capability is there. So all these aspects will be covered in the program elective one part of it. Program elective 2, we have automotive electronics, where you will get to know some aspects of the electronics involved inside the vehicle: ECU, campus communication, sensors, actuators. How do they integrate or interact with each other? All those things will be covered in the program elective 2. And we have the energy storage system lab. Smart grid laboratory is also part of the curriculum. So smart grid, as you all know, when we are integrating electric vehicle to the grid has to be smart. Otherwise, there can be a huge disruption in terms of increased load and less generation. All those problems will be there. So smart grid aspect of it, how do we have smart meters, right? How do we integrate the smart meters and make them talk with the electric vehicle powertrain? All these aspects will be covered in that particular aspect. Along with that, we have research methodology and IPR, so that these uh, these courses, when research methodology and IPR is being taught, you will have an understanding on whether you want to pursue your career on in doing better research on EV technology or the automotive aspect, or you can turn yourself into some entrepreneur. You want to maybe develop some product, right? How do you generate patent for that? All those aspects will be covered in that. We have one of our USP, we can say, is our holistic education. So basically, this particular course is aimed at it's something like what you have learned in your schooling, like moral science, but at this juncture, it is required for us as citizens of India to have some kind of responsibility to our country. So holistic education is one topic which we offer from the university, so that we enable the students to be moral and responsible citizens of the country. So that is a course which you can will find enjoyable. Yeah, semester two, basically, as I told, there will be topics on battery management system, digital twinning. Then comes the next vertical, that is software defined vehicles. And then thermal management part of it is also important. So that aspect will also be taken in. There will be a mini project which will be evaluated for 2 credits, 50 marks, which will be part of the base will be laid out in semester one itself. so that you can start preparing for this mini project in semester two. So when you're exposed to such a lot of topics, such a lot of facilities which are available, mini project will be very easy for you to do. But that will give you a lot of inspiration to align yourself to a particular stream. So if, for example, if there are some 20 students in our class, some five or six might be interested in in the energy storage part of it. Some five or six might be interested in software defined part of it. Some five or six might be interested in the grid part of it, or power quality smart grid part of it. So there you are defining yourself into the research teams, and that will help you a lot in your future to tune yourself into very much good researchers as well as good industry persons. So that is what you will get a platform for, right? In the semester three, there will be something on software verification, validation, some function safety standards. All these are required because we are going to do or have hands-on on actual batteries and all. So, what are the precautionary measures that are required to work on these batteries, right? Because anyone cannot be seen to work on. You cannot find a EV workshop at every corner, right? Because there should be some kind of certification which has to be given to the people to use, because it is a, you're playing with high voltage, high current aspects, and it is very dangerous as well, right? So how do we get certified? How do we become responsibly using or repairing these vehicles? So all these kinds of information has to be given, and that is what we'll be concentrating in the third semester. And in third semester, you'll be starting with your project work phase one. So as I told, from semester one, the base will be set. You will be identifying yourself into some research teams, and the second, the immediate development will be seen in semester two, where you'll be doing some mini project, and then continuation to that you will take up in your project work phase one, right? So so that will be having a much more bigger scaled up version of what you have done in a mini project, and you will culminate all these in the semester four, which can be an industry project as well, right? So semester four you will have a industry project where you will have phase two and dissertation. So what you have already done in semester one, two, three will help you out in getting connected to the industry, and you will be working on an industry problem statement which will be aligning to the project line which you have taken. So this is how we have structured the MTech program. Okay. And this program, as I told, will be for 2 years. Okay. First, until third semester, you will have classes, right? And fourth semester is completely project. It is it will be very much flexible in sense of like you will be having a lot of time to spend in the laboratory, and you will be having a lot of hands-on experience which is required for you to be well employable as well as market ready. So that is the overview which I wanted to give. Any points which you feel like you had to discuss, you can say. Vinayak sir, any other points which you want to discuss?
Most of the things I've covered.
Okay.
I think let's walk them through with the application process, how they can go to the price website and
Yeah, sure, sure. Maybe I'll show you the website part of it. I'll just take you through the website part quickly. So you can log into christuniversity.in. There in admissions, you can go to admissions. There undergraduate and postgraduate program. There under postgraduate, because you are applying for postgraduate, you can just scroll down, go to School of Engineering and Technology. So christuniversity.in admissions, postgraduate, School of Engineering and Technology. Under that, electrical and electronics, you will find MTech in EV technology. So here, if you click on this, it will open up to this page. So May 18th is the last date for application, right? And all the details regarding the course will be provided here. You can click on apply, and once you click on apply, you will be taken to this page where how do we do the registration? Everything is written here. Okay, so you can you have to first register here, create an account for yourself, and then register in, and then follow the instructions and do complete the form. You will might be required to keep your 10th and 12th marks in hand so that you can enter it accordingly. Bachelor's in technology is or bachelor's in engineering is expected. Okay, departments, we are offering it to all the departments because it is a completely interdisciplinary branch. So whether you are from triple EEC, electric, mechanical, automobile, you can take this course up, and your maybe some topics might be new to you, maybe power system related topics if you are not from electrical or electronics. But those courses also will have a prerequisite provided so that you might not feel too much of a difficulty to follow those things. Again, that will be only one subject because no, one subject in the sense one line. Okay, so based on your interest, you can follow. If you want, if you are from computer science and you want to have more on software defined vehicle, even though the course of from the power quality power system will be there, but you will when you talk in terms of your research curriculum or projects and all, you can concentrate on software defined vehicle based project development. So if you are really interested in energy storage, you can focus on that and do that. So that is how you log in to the website and complete the registration part of it.
We have a question. Dinesh has asked, what about college fees?
College fees is there in the website itself. I'll just yeah. So your application fee, I think, is around 1,700. Once you apply, you will be called for an interview. A small test will be there. Test in the sense it will be mostly on your know-how on, because you are going to take a particular course on EV technology. So some basics on EV based on that. And then there will be an interview. And after the interview, if you get qualified, then you will get into the admission process. So there you will your process will start from here, admission registration, and then this will be the fees for various uh, branches. Like if you're from Karnataka, you'll have a fee of this much. Other states will be this one. If you're an NRI, it will be this. And if you're from a foreign national, then you'll have something like this. So that is how the payment fees are. You can go through it in the website. All details are there.
Thank you for the session.
Yeah.
Thank you, everyone, for this session. If you have any queries, you can let us know. You can directly go to the links we have shared, and you can contact us and explore the course. And thank you, Parag sir, for walking through the course.
Thank you, sir. Thank you for getting these people ready for attending the course. Thank you.
Thank you, everyone. Thank you
Thank
for
you.
guys taking up the course and seeing you out here. Thank you.